Okay, so as we wait for the computer to kind of catch up with us here, we are moving on to mass. Somebody share with me the learning target for mass. All right, go for it, Kendra.
I can use the metric system to measure mass. More specifically, I can use a triple beam balance correctly.
Okay, so we're going to go over some of the instructions and some of the rules for mass. We may or may not get to the triple beam balances today, but if we don't get them today, we will get to them tomorrow. Okay? All right, my computer doesn't seem to want to cooperate today.
Oh, it's cooperating.
Is it? There we go. All right, so we'll let it kind of wake up here. As we look at number 1 in the mass, let's look at which is larger. So we're comparing the English system to the metric system again. So that A, 1 pound or 100 grams. 1 pound or 100 grams. Give me a thumbs up if you think 1 pound is larger. Give me a thumbs down if you think 100 grams is larger. All right, so I got about half and half as I survey the class. As we look at it and as we circle which one is larger. Okay, we've got 1 pound is actually larger than 100 grams. So go ahead and circle 1 pound. As you look at number 2, you'll see 1 pound is actually equal to 453.6 grams. Okay, so we're filling in number 1 and number 2 together. 1 pound equals 453.6 grams. That is a lot. Okay, number 2, 1 kilogram or 1 pound. Which one do you think is bigger? Give me a thumbs up if you think 1 kilogram. Give me a thumbs down if you think 1 pound. Alright, so I'm seeing mostly thumbs up. I think you're using what I just told you. 1 pound equals 453.6 grams. So, okay, 1 kilogram is bigger. And as you fill in down below, 100 kilograms actually equals 220 pounds. So if you've ever gone to the doctor, or some of you might have scales at home that weigh you in kilograms, okay? If you ever step on a scale that is weighing you or taking your mass in kilograms, it looks like you weigh less, okay? It's always nice when you step on and you think it's kilograms, okay? All right, last one. 1 ounce or 1,000 milligrams. Thumbs up if you think 1 ounce. Thumbs down if you think 1,000 milligrams. Take a guess. Educated guess. All right, so I got, looks like mostly thumbs down, but I got some thumbs up. Okay, 1 ounce is bigger. Okay, 1 ounce is bigger. And when you look at it, 1 ounce of gold specifically is 28,349.5 milligrams. So 1 ounce, significantly bigger. Okay. So as you look at your notes, you should have number 1 and number 2 filled in. They were all the first ones today. Okay. All right. So number 3, when we talk about mass, mass is what refers to the amount of matter in an object. So I just completed number 3 for you. Okay. Mass is the amount of matter that's in an object. And based on our bell ringer, everybody should be able to complete number 4 for me. So I want somebody to read it and fill in the blanks for me. take a glance at number 4. Who thinks they can read it and fill in the blanks? All right, Luke, go for it.
The base unit of mass in the metric system is the gram, and it is represented by G.
Good. So we filled in number 4. The base unit in the metric system is gram, and it's represented by that lowercase g. All right, what's number 5 asking, Troy?
Is mass the same as weight?
Is mass the same as weight? Let's do thumbs up, thumbs down. Thumbs up, yes. Thumbs down, no. All right, I'm seeing all thumbs down, it looks like. So you're right, it is not the same thing. But ultimate question, though, why? Why is it not the same thing? All right, Jalen, start us off. Okay, so we're using that word weight, it's how much you weigh, but mass is how much matter is in you. So aren't they related at least? Okay, so now, but that's volume. Volume is how much space you take up. CJ, what do you think?
Mass is the amount of matter in you, and weight is how much gravity pushes down on you.
Good. Weight is affected by gravity. So as you answer that, okay, weight is affected by gravity. So if I take a trip to the moon and we all take a trip, Miss Wilson's field trip, we go to the moon, we get on a space shuttle, okay? Our mass and our weight, we take our mass and our weight here. And then we go to the moon and we take our mass and our weight. Will our mass change?
Yeah.
Our mass?
No.
Okay, we'll still be the same person. Okay, we'll still have the same amount. I'm not going to have you running laps around the space shuttle to lose matter. Okay? But when we get there, the gravity is different on the moon, so what changes? Your weight changes. Good. All right. So as we look at number 6 in your notes, let's fill in those blanks there. 1 kilogram equals how many grams? What do you know about the metric system? And based on what we talked about yesterday, where we had 1 kilometer equals, do we have that? 1 kilometer equals how many meters? It's very similar. 1 kilogram equals how many grams? What do you think, Angie? 1,000. Good. Okay, so number 6, 1 kilogram equals 1,000 grams. And then we've got 1 gram equals 1,000 milligrams. All right, so let's use these facts and let's work through number 7. 1 kilogram or 1,500 grams. Which one's larger? Which one is larger, Austin?
1,500 grams.
Why?
Because 1 kilogram equals 1,000 grams.
All right, so as we look, and you might just want to fill in, Austin told us 1 kilogram is equal to 1,000 grams. So when we compare that, we know that 1,500 grams is bigger. All right, let's do B together. 1,200 milligrams or 1 gram. Which one is bigger? Troy?
1,200.
Why do you say that?
Because it only takes 1,000 milligrams to make 1 gram.
All right, so he told us right here it only takes 1,000 milligrams to make a gram. So there, in that case, 1,200 milligrams is bigger. All right, I want you to look at your shoulder, buddy, and go through C and D. Take 2 minutes. 1 minute. Decide C and D. Talk it out.
Take 2,000.
So it's 12 kilograms.
Explain it.
What is it?
All right, who's got C? C, I think, is the easy one. Who's got C? All right, Cody. What do you think about C? 12 kilograms. Why? It's always hard when I ask why. Okay, we can look up here and we can, by looking at our metric units up here and what we wrote, we can tell that milligrams are a lot smaller than kilograms. Good. So it is 12 kilograms is bigger. All right, what about D? 4 kilograms or 4,500 grams? Which one's bigger? Sydney?
4,500 grams.
How do you know that?
Because there are 1,000 grams in 1 kilogram.
Good. So 4 kilograms actually equals 4,000 grams is what Sydney said. So 4,500 is bigger. Okay? All right, what tool are we going to use to find the mass? What tool are we going to use? And you can see some of them throughout the classroom today. What are they called, Abby? Triple beam balances. You can also, and yes, I will also be giving you a scale sometimes, but it's always important to know how to use a triple beam balance. So that's number 8. You will get some practice, and it's looking like we're close to running out of time, so we'll get some practice first thing tomorrow with mass, but let's go ahead and let's go through the steps. Okay, and I've got one up here that I'll kind of point out. So as we go through the steps for number 9, I'm going to come back to that side. All right, so first steps, did you do it last year? Good, then it's a review. So let's put the steps in and let's fill them in. All right, so first you're going to place the film canister or whatever you're measuring on the scale. Okay, and here's our scale right here on the silver part. That's your scale. So you're filling in number 9 with me. If I underline it, you know it goes in your notes. Okay. Then the second step, we're going to always start with the large weight. Oh, I underlined the wrong thing, didn't I? Okay, weight is what we should have underlined. To the right. So the large weight, where is the large weight? What arm does it sit in? You got 3 beams. Which one do you notice that it's in, Luke?
The middle?
It's the middle. So that large weight is the middle, and you can see that arrow in my picture pointing to that large weight. So we always start with the largest. Okay? And we're going to move it, and if I do it right here. So I'm going to move it until I see this arm over here drop down. Let's use something lighter. All right, so we start here, move it, move it, move it, drops down. So once it's dropped down, I'm going to move it back 1. All right, step 3, you're going to repeat the same process with the top weight. Okay, so I'm going to move it over. What do I need to underline up here? Top. Okay, so I'm going to do the same thing until it drops down. Okay, and then once it drops down, I'm going to move it back 1. Good, class. All right, and then my 4th step, I'm going to slide the small weight. So small on the front beam so that all the lines add up. So I'm going back to this right here, this line right here. I want it to add up. So I'm going to move this. Okay, I went a little too far. Okay. And then what do I do? Once I've got it even. Then what's step 5, Jalen? Okay? I'm going to wait till the beam stops, and then I'm going to do what? What am I going to do, Abby? Add them all up. Okay, so let's go to your number 9 or your number 10 real quick, and then we'll be done. So sit tight. I know the bell's getting ready to ring. Let's do number 10. Okay, let's look at this picture, and I know your picture isn't very clear on your notes. Okay, wait real quick. Top weight, I've got 70. That middle weight, I've got 300. And the bottom weight, I have 3.4. So what's the total mass of this object that we've taken the mass of in the picture? Troy? 373.4. Homework tonight, test analysis and ERQ if you have not finished it.